Welcome back to Algebra Express. We are in Marecek 5.1 and 5.3. In this section, we're going to talk more about polynomials. We're going to add, subtract, and multiply polynomials in this section. And so the first thing that we're going to start off with is getting a definition of what a polynomial is. And so a polynomial, they say, is a sum of terms in the form ax to the n. So they give us this definition. It's pretty math-based. And so I want to think what they're talking about here. So this, they're saying there could be a coefficient and there's a variable with a power of n. So here they're talking about the natural numbers, and they're including 0 in here, so it'd be 0 technically, I guess, or it's a positive energy. We can have something to the 0 power that is just a number. So if we have a variable to the 0 power, that would make this 1, and it would just be sort of like the coefficient there. And we might see something in just a second. So we want to talk about these things that are polynomials. So like I said, it has a coefficient, it has a variable, it has a power, and it says it's a sum of the terms. So it should be all addition and subtraction. So if it's subtraction, that just means that your a was negative. So I've said this before, but I can look at this sort of like we're adding a negative 4x squared. And in general, that's the way that my brain probably is just going to like automatically sort of process these things. I'm going to look at it as plus a negative, and that little coefficient is going to be negative on the x squared. And then we have plus x. And so I don't see a power on this thing. If I don't see a power, I can always write a power of 1. 1's a positive integer, we're safe. So it has a coefficient, it has a variable, it has a power. There's some adding and subtracting between the terms. It has a coefficient, has a variable, power. There's some adding here. We don't see a coefficient here either. So if we want to talk about a coefficient, we could also put another 1 there. And so I didn't say it, but a, our coefficient. And so if we have something like pi x plus 8, the coefficient's pi. The exponent here, if I don't see it, I can write a 1. And I see this thing plus 8. And it's not there. There is no variable there. And so if I want to think about it, it's kind of a stupid way to write the variable. But if I wanted to do it, I want to talk about how many x's are here. There are no x's there. So if you put this as an x to the 0 power, and go back to the previous section, x to the 0 is just going to be 1. It's not going to change it if I put it there. We're just multiplying by 1. So I can think about things that are just coefficients or just constants as being variables to the 0 power. Same thing with the 7. I can think about this as a constant here. But if I really want to think about how many x's are on there, what power of x would be on there? It would be 0. And so these are things that are polynomials, and I think we did I'm tooting my own horn now. Hopefully we did a good job of covering like why those are polynomials and why it fits this definition, right? We have terms that look like this that are separated by sums, which means addition or subtraction if your a is negative. Okay. Why are these not polynomials? So I think the first thing that probably sticks out, the thing that makes it different, is that square root. And we really haven't talked about it, but if I wanted to put a square root power, a square root, it's an understood 2 if it's not written there. So this would be like a fractional power. And if I write it as a fractional power, this is not an integer, right? It is a fraction. Integers are like whole numbers and zeros, right? So, since this is not an integer, this is not a polynomial. And I could write it and finish it off. But this guy isn't the thing giving me a problem. It's this guy right here. This is x to the pi. I want to spend a lot of time on that, but pi is not an integer. This is 1 over x, and we talked about this. But this is like x to the negative power. And so that is negative, and so we are not including negative powers when we talk about polynomials. Okay, so they want us to dissect this polynomial. They want us to write the term here, the coefficient on that term, and then the degree of the term. And so we're going to define a lot of words right here, and then we're going to talk about the degree of the polynomial and the leading coefficient after we're done with that. So I want to grab, where's my pen? There we go. And let's grab the third color right quick. Yeah. Multicolor this right quick. Okay, so let's look at this. So I want to underline term by term minus x. Minus 8x to the 5th is the first thing I see. Plus x to the 4th. And you should really grab the sign of x here, because this is a minus 2x. And the last thing I see here is a minus 3. So for the term, I want to write the whole thing I have underlined there, the minus 8x to the 5th. Okay, and if I want to know what the coefficient on this term is, what is the coefficient here? So the coefficient is the thing that is not the variable. The coefficient here is minus 8. The degree of this refers to the power of your variable. So the power here is 5. So this is okay. The next thing I see there is plus x to the 4th. So I have an x to the 4th. My coefficient on this thing. So if I don't see a coefficient, always write 1 on there. And the degree on this guy. Okay, and the next thing, hopefully we're getting the hang of this, is a minus 2x. So be sure to grab your sign, minus 2x. The coefficient on this thing. And now the degree. So this is one of the sorts of things you're going to have to start seeing. If I want to put an exponent here, it would be an exponent of 1. And the last term I have in this polynomial is a minus 3x. It looks like a minus 3. My coefficient here, and this is that thing I said, right? If I don't see it, I'll write an x to the 0. There are no x's on there. My coefficient here, it is the minus 3. But my degree here is the thing that might be a little weird, is the 0. So if it doesn't have a variable, then we're talking about degree 0. So we want to talk about the degree of the polynomial. And so now they kind of just throw this out at you and don't talk about what it is. So I guess we kind of need to define it a little bit. But the degree of your polynomial is the highest degree that you have there. So if we're looking here, the highest degree is going to be right here. So they have this thing written in a really nice descending order. But my degree of my polynomial is a degree 5 polynomial. They say leading coefficient. I want to talk about the leading term first. So if I want the leading term, that is the largest term. It is literally the leading term, the first term that you have written. So if I want to talk about the leading term, it's that minus 8x to the 5th. If I want the leading coefficient, it's literally the first number that's there then, that minus 8. Okay. So we talked about polynomials. We defined what a polynomial is. We talked about the coefficients in degrees. Okay. And now we're going to talk about adding polynomials. So if we have 5y squared plus 12y plus 4 plus 6y squared minus 8y plus 7, there are a few things we know about addition, right? And so we can use we can use the fact that it is what, associative and commutative, and this goes back to like the previous, I believe I did this in the previous notes, something very similar. I can currently look at this 5y squared as being added to this 6y squared. I can look at this plus 12y being added to the minus 8y, and plus 4 and plus 7 will go together. So I can kind of rearrange these things. And I'm not expecting you to maybe write this step. You could probably skip this step if you're doing the work. The point of this is that I'm adding the y squareds with the y squareds, right? You're adding like terms, and you can add those like terms because addition has these really nice properties where we can drop the parentheses, we can regroup things. 12 minus 8, I believe it's going to give me what, 4y. And I believe the last thing is going to give me what, plus 11. So we do 5 and 6 will give us 11, 12 minus 8 gives us 4, and 7 and 4 will give us 11. So adding polynomials, the rule to adding polynomials is that you add like terms. Okay, so the next page, subtracting polynomials. So there are essentially two sort of ways I can think that you could go about this. So if you need to, but the first way I want to go about it on this first one is I want to distribute the negative sign. So if I distribute the negative sign, this looks like x squared plus 5. I'm going to distribute this to make it a minus x. I'm going to distribute this to make it plus 7. So if we do this, and I'm going to write it in probably in descending order, so x squared is going to come first, minus x. And if we look, we have like terms that we can combine here. So we have 5 plus 7. This should give me plus 12. And in general, I would probably recommend distributing this thing. The other way you can do it is you can do it term by term. So x squared, there's nothing for it to minus over here, so we keep it. 5 minus a minus 7 will give you the 12, and then the other thing we missed is the minus x. So I would probably suggest distributing it first. You're less likely to miss terms. 3b squared minus 4b plus 1. And I want to make this addition. I have to distribute that negative. So I'm distributing this negative. I want to make this a minus 5b squared. I want to make this a plus b and plus 2. So if I do this, I am adding two polynomials. So the rule here is find like terms. 3b squared minus 5b squared is going to give me minus 2b squareds. Minus 4. And we're going to add 1 to it. So that is minus 4, and it's going to come up 1 to a minus 3b. And now plus 1 and plus 2 now is going to give me plus 3. Okay. I just noticed they're a really great numbering system. We go 1, 2, 3, 4, and now we're on problem 10. But that's probably because they pulled it out of somewhere else. So we have a word problem. Ace Manufacturing has determined that their new phone will have a revenue function, and they give that revenue function R of x equals 16x minus 0.212x squared. And a cost function C of x equals 24 plus 8.2x, where x represents the number of phones produced and sold in thousands. Revenue and costs are given in thousands of dollars. Recall the profit is given by P of x equals R of x minus C of x. Write the profit function P of x. So maybe we need to talk a little bit about like what these things mean. So you're running a business. What is profit? The unpaid wages of your workers. So anyway, we have these three things called revenue, cost, and profit. And so to make sense of these a little bit, when you're running a company, everything you sell, all the money you're taking in is going to be considered your revenue. Everything that you spend to make your product is going to be your cost. So if you take all the money you're taking in and you subtract all the money that you're spending to make it, that net profit, right? That net gain there is your profit. So whatever gain you're making by selling these sorts of things, after taking off the expenses, right, is going to be your profit. And so what they're doing is they're coming up with a function for your revenue. They're coming up with a function for your cost. And if we subtract cost from our revenue, we will get to our profit. So we have two functions, and we're creating a third new one through operations on those previous two, is essentially what we're doing. And this new function has its own name. It's its own distinct function from the other two. And so we need to write out what this sort of equals R of x is 16x minus 0.1 x squared. So R of x, I can write 16x minus 2x squared. And I have to subtract my cost. And so before I do this, minus 24 plus 8.2x. I'm going to do it, and it's going to hurt my eyes. What should I really do when I start doing this? And this is one of those things every mathematician loves, probably a little too much. But when I'm plugging in these functions, when I'm putting these whole terms in there like this, I should really put some parentheses around it. If you don't put your parentheses, you're probably going to miss that it's getting distributed to both of these things, right? So that negative really got to get distributed. So there we have it. P of x is this thing. We can do a little bit of cleaning up on this thing. So we've done a few problems like this. So this is 16x minus 0.12x squared. If I distribute this negative, this is minus 24, and this is minus 8.2x. I'm going to lead with the largest term. That minus 0.12x is the first thing I see there. Or it's the largest exponent. So the next thing I'm looking at is what? 16x and minus 8.2x. So if I take 16 minus 8.2, that's going to give me plus 7.8. And this has an x attached to it. And the last thing I have is minus 24. So I can carry this all the way down, but I'm talking about my P of x function. So this is a function. I have this function, I have this function, and I have this function. So we derive this function from the other two, but it is its own distinct thing. I can give it its own name. And I can talk about profit without having to talk about the other things, right? So I have this. This is my P of x. And now they want us to evaluate and interpret this thing called P of 60. So P of 60, and we've done stuff similar to this before, but P of 60 is going to plug in 60 to my x. So I have to plug in 60, and I have to plug in 60 everywhere there's an x. So I got to do what? 60 squared, and I got to multiply it by 0.12. So this is minus 432 plus 7.8 times 60 gives me what? 468. Subtract 24. So I do minus 432 plus 468. Subtract 24, and that should give me 12. So P of 60 is going to give me 12. So now I gotta come back and I gotta interpret this thing. What does it mean in context to this problem? What were we manufacturing? I think we're manufacturing new phones. Let me make sure we got all the units correct. X represents the number of phones produced and sold in thousands. So X is the number of phones in thousands. Revenue and cost are given in thousands of dollars. So this one is your phones in thousands, and this one is your profit in thousands of dollars. So maybe we want to write a sort of sentence to capture this. The first is 60,000 phones. If you sell 60,000 phones, your profit will be $12,000. I hadn't done it yet, but there's another sort of way you can probably approach this. If we know P of 60, R of X minus, or P of X is R of X minus C of X, and P of 60 is R of minus C of 60. You can go and plug this into those other independent functions. We can plug 60 into this thing. Or I can plug 60 into this thing. I guess I can do it right quick. 16 times 60 minus 0.12 times 60 squared. And that's going to give me something like 528. Hopefully this works. Doing it live. Okay. And I can plug 16 into the other thing. 24 plus 8.2 times 60. That should give me 516. So if I do 528 minus 516, that gives me 12, which is what we got previously. So you can do these separately, plug them into each separate function, and then calculate it. Or you can do it all in one go, because we figured out what P of X was symbolically, right? We did it symbolically. So that's kind of like plugging it in here versus plugging it in here, right? It's the same formula, so it shouldn't matter. Okay. Next thing we have the sum of two functions. So we talked about subtracting two functions. And it should be similar notation. But we're going to start with sum of fractions. So f plus g of x equals f of x plus g of x. So if I want to find f plus g of x, write out the definition. So my advice with these is if you see multiple sort of functions or something happening with multiple functions, go back to these definitions. We know the definition is f of x plus g of x. So I want to take my f of x. That's the minus 4x cubed. And I probably don't really use this. Once you add g of x, which is a minus 2x. I should throw my equal sign in there. So we have this thing. We're looking at it. And so what we really need to look at is like terms. So I have this thing. I want to leave it my largest term. Put it in the minus 4x cubed minus 2x squared comes next. And now we need to do a little bit of number crunching. Plus 7 minus 10. We can combine those to minus 3. Okay. So that's added to them. Now we're looking over here. If we want to do f plus g of a minus 2, I can do f of minus 2. That is absolutely one way I can sort of do this thing. I can go plug in minus 2 to my f function and go plug in minus 2 to my g function. Or so if I want to do f plus g of minus 2, I can also come right here and plug it into here. And then this is probably the one I'm going to do because it's solved. It's a little bit less work. If I do minus 4, I do a minus 2 cubed, I do a minus 2, and I do a minus 2 squared, and then I subtract 3. So let's crunch this. The minus 4, minus 2 to the third is a minus 8. Minus 2, I have a minus 2 squared here, so this is going to be from a positive 4. So doing PIM does one step at a time. Don't try to do too many things at one time. And make sure you count your negatives. If I have 3 negatives, overall it's negative. If I have 2 negatives, overall this thing should be positive. Minus 3. This is positive 32. I'm going to subtract 8 and subtract 3. This should be giving me 21. Okay, so now we want to talk about multiplying polynomials. So we've added, we've subtracted, now we're getting into multiplication. So the first sort of thing, they kind of divide this up into monomials times polynomials, and then in a second we'll do polynomials by polynomials. But this looks more like I can't even speak anymore. This looks more like the distribution law. So use your distributive techniques. We're multiplying this by everything throughout here. There are 3 terms. There are 3 different things that should get multiplied. I'm going to go minus 3ab. I guess I'll go ahead and write that right here. I'm going to multiply that by a cubed. Minus a squared. I have to multiply this by minus 3ab. And I have 4ab squared. And I have to multiply this by a minus 3ab. I don't really like the way that looks. I'm going to change this around a little bit. You have to write this thing out, write it out. But I think if we look at this, so minus 3ab, I want to multiply coefficients to coefficients and exponents get added to exponents. Minus 3ab, so this is minus 3, a to the first power, b to the first power. This is 1, a to the third power, minus a squared b. If I don't see first powers, they're there. If I don't see coefficients, they're there. They're 1. So if I look at minus 3ab, the first thing I'm doing is coefficients to coefficients. Minus 3 times 1 will give me minus 3. I have an a to the first power, and I have an a to the third power. So 1 plus 3 should give me 4. And I still have a b I have to account for here. Next thing, I look minus 3, I do coefficients to coefficients, minus 3 times a minus 1, a positive 3. The next thing I'm looking at is my a's. So I have a1 and a2. a1 plus 2 is going to give me I have b to the first and I have b to the first. B to the 1 plus 1 is going to give me 2. So the thing, well, let's go with another one. This would be better to look at. So minus 3 times positive 4 is minus 12. Next thing I'm looking at here is a to the first and a to the first is going to give me a squared. B to the first and b squared is going to give me a b to the third. So I think the important thing to remember is the coefficients get multiplied, the exponents get added. And we just kind of go down the line of this thing that we're multiplying. We start with the minus 3, we go to the A's, and then we go to our B's. Okay, so if you have to write middle steps, I guess go ahead and write them. But I feel like at some point, hopefully you can jump to not having to write that thing out 3 different times, right? So that is if we're multiplying a monomial by a polynomial. We multiply that one thing to all the different terms in there, just like we did with distribution. So now we're doing polynomials by polynomials. And I forgot how to drink, so there we go. Multiply each term and first to every term and last. Okay. So one of the ways that people say this is FOIL, right? First adder and last. It's a pattern. It's okay. It works. But it only works for a binomial by a binomial. So let me grab some colors. Here we go. So what I want to do is I want to take this 2y and I want to multiply it by everything over here. This is the way that I sort of do these things. I will start with the first thing over here and I will multiply it through. Then I will come through. I will take the next term, minus 3, and I will multiply this through to everything. So I have 2y times 3y. I have 2y times minus 7. I have minus 3 times 3y, and have a minus 3 times a minus 7. If you have to write out this middle step, that's fine. But I feel like at some point, maybe, hopefully we can get like beyond writing out these middle steps. So 2y times 3y, I'm going to multiply coefficients by coefficients. So 2 times 3 is going to give me 6. Y to the first, and y to the first is giving me y squared. 2y minus 7. Minus 7 and minus 2 makes it minus 14, and it's got a y attached. Minus 3 and 3y is going to give me, minus 3 and 3 is going to give me minus 9, and these things have a single y attached. I have minus 3 and a minus 7, that's going to give me plus 21. 6y squared minus 14 minus 9 gives me what? Minus 23y, and I have what? Plus 21. Okay. So I think it's the first we're going into distribution, huh? Of polynomials. There we go. So we're going to do a lot of work going one way, and then we're going to do a lot of work going the other. Is essentially what we're going to do in this class. We're going to do a bunch of distribution. So I've said it before, and I'll probably say it again. This class really builds on itself. So keep on track. If you get lost, it's really likely to kind of spiral, right? And we don't want that to happen. Trying to get y'all through this class just as much as you're trying to get through the class, I promise. Okay, so now we want to multiply things, polynomials by polynomials that aren't just 2 terms. So how do we do that? Then you're probably lost at this point. Well, maybe not, but it's like an extension of that, right? So same thing. I want to take this first term and I'm going to multiply it. Now I got 3 different things I'm multiplying here. Same thing here. I'm going to multiply this to 3 different things. So the first thing I see there is a squared times a to the third That's a to the 5th power. The next thing I see there is a squared minus 4a squared. The coefficient there is minus 4. There's just one here. And I'm going a squared, 2 plus 2 is going to give me 4. Now I'm looking here, a squared plus 2a. So this is plus 2 is the coefficient, and a squared plus 1 more is going to give me a to the 3rd power. Now I'm looking, plus 5 times a cubed is plus 5a cubed. Plus 5 minus 4 is going to give me minus 20. And this thing has an a squared attached. Plus 5 plus 2a is going to give me plus 10, and this thing has an a attached. So this, we've done most of the work. We did the hard step. There's like maybe one little thing we can simplify in here that I see. So you have to check and make sure you don't have any like terms. Minus 4a to the 4th. So what? Plus 2 plus 5, I believe, gives us plus 7a cubed. Minus 20a squared plus 10a. Okay. And again, you're not going to learn math without getting your hands a little dirty. So hopefully you're trying these things. We have this, and we have about one more page for you to really get into things on your own. But we're getting around to the last sort of concept that we're learning, huh? Now we're taking around, we did multiplication of polynomials. So now they're going to give us 2 polynomial functions with a bunch of words and make us regurgitate what the English to math sort of thing means, right? So we have this thing, it says on hot days, an ice cream stand sells more ice cream and can charge more for each ice cream cone sold. For a given temperature T in degrees Fahrenheit, between 70 degrees Fahrenheit and 100 degrees Fahrenheit, the function P of T equals 0.05 T minus 1.55 determines the price for each ice cream cone in dollars. And the function D of T equals 10T minus 650 determines the consumer demand and number of ice cream cones. Revenue is calculated by that. So we're talking about revenue now. They're doing what? Price times the demand. So this is like the price of the ice cream cone, and the demand would be like the number of ice cream cones people are demanding, right? So we're doing the price per ice cream cone times the ice cream cone is essentially what we're doing. So we want to find the revenue function R of T, and they kind of tell us R of T is P of T times D of T. And so what are we doing here? Write it out. P of T is 0.05 T, and I did it without even being told now. I'm just putting parentheses around things. So 0.05 T minus 1.55, and we're going to multiply that by D of T, which is 10T minus 650. Okay, so this is very similar. It's a little bit more messy since they give us like some real numbers. Make sure my phone's charging so it won't die off in the middle of a lecture. But here we go. We want to do the same steps. First, multiply everything through. Second one, multiply everything through. Yeesh. So definitely, probably grabbing a calculator at this point to get these numbers a little quicker. But 0.05 times 10T, so 0.05 times 10 will give you a 0.5. And we have T times T is going to give me T squared. The next thing I have 0.05 times 650 times the minus 650 is overall going to be negative. This is going to be negative 32.5, and this thing has a T attached to it. The next thing I have is minus 1.55 times 10 is going to be minus 15.5, and this guy has a T attached to it. And the last thing is minus 1.55 times a minus 650. So overall, this should be positive. And this is going to be 1007.5. And so we're looking at this thing. There is a little bit of cleaning up we can do. Minus what? 32.5 minus 15.5 should be what? Minus 48t plus 1007.5. And so this is our R of t function. So if we want to evaluate R of 90, this is equal to 0.5, and have to do 90 squared, and have to subtract 48, and have to multiply this by 90, and have to add 1007.5. Okay, so if we do this, this gives me 4050. This gives me 4320. And this gives me plus 1007.5. So 4050 minus what? 4320 plus 1007.5 is going to give me 737.5. And so now we got to come back and reinterpret, like, what does this mean? So R of T. So going back, what does T mean? T is the temperature, T in degrees Fahrenheit. So what we're talking about here is when it's 90 degrees Fahrenheit, the revenue is the other variable. And do they say what it is? They're talking about in dollars. This determines the number of ice cream cones in dollars. So if this is in dollars, if the price is in dollars, then our revenue is also going to be dollars. When it is 90 degrees Fahrenheit, the revenue is 737.50. We're going to add that 0 to make it a cent. Okay, so that is the word problem. And now we get to a few activities. So hopefully you're trying these on your own. You should be able to do these, or at least make an honest attempt at them. So I'm going to go a little bit quicker over these things, so because you should be doing them on your own. And so the first thing I want to do is make this 3x times 4x is going to give me 12x squared. I'm going to go plus 15x. I'm going to go minus 28x. And the last thing is what? Minus 35. I can combine like two terms there. 12x squared. What's this? 15 minus 28 is going to give me minus 13x. And this is going to give me minus 35. Here we want to multiply the two things. Don't read that. So I want you to just for a second, pretend like you didn't read that. You want to do this, right? And you want to do it as quick as possible. Huh. So a lot of people will tell me 2x squared plus 25. Something like that. Maybe we'll do it a little different. Is that correct? Don't do this. I don't know how many times I say this. Don't do that. Please don't do this. If you see something that is a polynomial, right? It's got multiple terms. It's got some kind of addition, subtraction, and we're putting a square up here. So if this was like, okay, so we're going back. We had that property in the previous section, right? Let's throw some numbers up here just so they're all different. A squared, b to the third, c to the fourth. If I went and did 3, I can absolutely distribute this thing, a to the 6th, b to the 9th, c to the 12th, right? That is fine. And that is fine because if we look at the operations in here, everything is being multiplied. This is one single term that we can distribute our exponent into, right? So, but when the second I throw in a plus or minus, anything like this, right? Guarantee you, write it out twice. If you don't write this out twice, I'm going to yell at you, write that out twice. You have to write this thing out twice because if I just said a squared plus 1, right? But I want to be fast with this, right? A squared plus 1, don't do that. Why is that? Because you're going to miss your middle term. This is a squared plus a plus 1. You're going to miss 2 a's. Same thing with this. If you just do, I don't know what the heck you're going to do, 2x squared plus 25 or 4x squared plus 25, whatever you do, you're not going to get it right. Write it out twice. If you see this, I hate that they gave it to you in the notes. Write this thing out twice. Because when you stumble and when you fall and you're like, you learn that path a little bit better and you're like, I ain't falling down that hole again. Not waste a good time doing that. So this is 2x times 2x gives me 4x squared. 2x plus times a plus 5 gives me plus 10x. 5 times 2x gives me another plus 10x. And the last thing I have here is 5 times 5 is giving me 25. So this is 4x squared plus 20x plus 25. Okay. And the next thing, multiply 3z plus 5 times 3z minus 5. Same thing here, first term gives me 9z squared. First term, outers, I guess. 3z times minus 5 is a minus 15z. 5 and 3z give me plus 15z. And the last thing I have is plus 5 minus 20. Minus 5 gives me minus 25. Ooh. 9z squared. Okay, so I'm looking here. I see 9z squared. I see minus 15z. I see plus 15z. So I guess I'm going to write it. That gives you plus 0 z's in the middle. But really, I don't have to write it, right? So you're probably not going to write it most of the time. This is no more z's. It just looks like 9z squared minus 25. Okay, so we see this. That is definitely not part of that. But we see the special products. So if we see products of conjugates, like a plus b, a minus b, let's get a special thing we can go to. If we see square binomials, like a plus b squared, this is the way it works. It doesn't just go to a squared plus b squared. All right, this is the thing I was ranting about. If you don't write it out twice, you're bound to miss this middle guy. Write it out twice. But now they want us to do this. They want us to do this from the formula. And so a little bit about maybe what they're talking about. They say a plus b, a minus b. So if we look at, let's look at 7, and then let's work our way back up. So 7, you might notice this is the conjugates one. So what they're saying is that this is a plus b, a minus b. So if you notice it's in that form, then our a is going to be 3z, and our b is going to be 5. And we want to get to a squared minus b squared. So we don't know what a squared is, we don't know what b squared is, so that's probably the first thing we need to figure out. So if we square this, and again we go 3z times 3z, don't forget to square the 3. The z also gets squared. B, if we square it, is going to be 25. So now if we go and plug it back into this formula, this is the form it should be in. It should look something like what? 9z squared minus 25. And if you notice, that's the solution we got there. So if you notice it's in this form, you don't have to do all that work. If you can notice it's in the appropriate form. This is also known as a, well, this one is known as a difference of squares. And so, like I said, we're doing distribution now. We're going one way. Another way, after we do distribution, we're going to do factoring. And so we're going to look at things that look like difference of squares, and we're going to jump back to its factored form. So this is its distributed form. Sometimes it's called difference of squares. The other thing, square of a binomial. So if we see something like 2x plus 5 being squared, this is like our a, this is like our b. So this is the a plus b squared form of the polynomial. So again, my a is 2x, my b is 5. I'm probably going to have to figure out what their squares are. So if I square 2x, that's going to give me 4x squared. If I square b, that's going to give me 25. So now I got to plug it into this thing. So a plus b squared is going to be equal to a squared, which was my 4x squared, plus 2, and I want to do a times b, 2x times 5, and now I'm doing plus b squared, which is what, plus 25? And I'll be doggone if that doesn't give me what, 4x squared plus 2 times 2 gives me 4 times 5. This is going to be 20x over here. Plus 25, isn't that the same number? Oh, gee, look right here. That's the same thing we got for that guy. So if you notice these things are in a certain form, personally, I would not go with this one. I think the product of conjugates might be a little more obvious, maybe. This one, I would actually suggest, if I saw this on a test, saw this anywhere, I would highly suggest, like I said already, if you see a polynomial being squared, write that sucker out for squares twice, right? If it was cube, you would have to write that sucker out 3 times. So most of the time we'll be working with squares. I think you'll be safe with squares. But that looks like the end of it. That looks like the last problem. And so hopefully I will see you all soon.